Now you've modeled discrete dynamic systems in Simulink. Excellent. But how does Simulink solve those discrete dynamic systems when you click the Run button? Discrete dynamic systems update their states values periodically. Simulink ensures the states values are correctly computed by taking a time step whenever a discrete state needs an update. How this happens is handled by the solver. In this module, all the models contain only discrete states, so Simulink will use a discrete solver to solve these systems. For models that also contain continuous states, Simulink will use a continuous solver. There are two types of solvers. By default, Simulink selects a variable step discrete solver for discrete dynamic systems. So, what does the solver do? Well, at a high level, at each time step, Simulink calculates the block's outputs, calculates the discrete states that require updates, and determines the simulation step size to get the next time step. Let's look at how this process works with an example. When you click Run, the simulation starts at time 0. First, the block outputs are calculated. Some blocks' outputs depend on other blocks, so those blocks' outputs need to be calculated first. Since this order is the same for all time steps, Simulink initially analyzes the model and automatically determines the block execution order. You can use an information overlay to view the execution order. Here, you may have noticed that Simulink computes the unit delay block's output first. Well, that's because it contains a discrete state. So its output at time 0 is the state's initial value and doesn't depend on any other blocks. From there, other blocks' outputs are calculated in sequence. After all the outputs are calculated, the unit delay block updates the state by holding its input for one sample period. In this example, the discrete state updates every 0.5 seconds. So the time interval between simulation time steps is simply 0.5 seconds. But as you've already seen, some discrete systems are more complicated and have multiple sample rates. In such a case, each state updates periodically, but the update period can be different for each state. The variable step solver takes a step whenever any state needs an update, and the solver step size may vary. At each time step, the solver calculates the block outputs and updates the states. Those states that don't need an update at a given time step hold their previous values. You can use a fixed-step discrete solver if you need to deploy your discrete system to hardware that operates at a fixed rate. The fixed-step solver takes additional time steps to ensure the step size is constant and all the outputs and discrete states are correctly computed. Now, let's explore how Simulink solves your model.